Hello, I'm Dave Brown, and today we're going to talk about roller chain. Roller chain comes in all sorts and sizes. For example, here's a piece of number 25 chain, which is the smallest size of normally stocked roller chain. Here's a piece of number 140 chain, which, as you can see, is a great deal larger than the number 25, but roller chain does come a good bit larger than this. Here's a piece of number 60 roller chain. It would fall into the intermediate classification. Now, to most people, the term roller chain doesn't mean much, and the family bicycle is probably their most experience with roller chain. Here you see a standard bicycle chain. It is roller chain, and it is used and sold for commercial applications. Now, let's take a look at the components that go to make up one section of chain: the roller link and pin link. First, the roller link. It's composed of two side plates, two bushings, and two rollers. The roller fits over this cylindrical bushing, and the bushing is then pressed into the holes on the side plates. The bushings are a press fit into the side plates, and as you can see on this complete roller link, the roller is free to turn over the bushing. The pin link, on the other hand, is composed of two side plates and two pins. The pins, in this case, also are a press fit into the side plates. The side plates are what is known as through hardened, which means that they are the same hardness all the way through the material. The pins, however, are normally case hardened in the center section, which means that there's just a little skin of hardness on the outside, and the center is ductile and tough. The ends are left soft so that they may be bradded, as you see here, or so that they may be drilled for a cotter pin, as you see here. Now, there's a unique situation pertaining to the industry that I should point out here. The cotter pin and the brad on a normal chain assembly are not necessary at all. This procedure started back at the time when bradding was necessary because the equipment was not available to press the pins into the side plates with sufficient force to keep them in place. But today, the only reason for brads and cotters is custom. People expect it. The roller is the prime ingredient of roller chain. This free-moving component assumes a different position every time it hits one of the sprocket teeth, and as a consequence, reduces the wear on the chain as well as the sprockets. Side plates, if you'll notice, are a figure 8 or wasp waist shape. Now, the term wasp waist being associated with the actual shape of a wasp, or similarity to an hourglass. The curvature of this plate is only to reduce the weight of the unit and does not reduce its strength at all. Now, there are types of side plates that have a straight edge, but there's a particular reason for this, and we'll discuss that in a moment. Now, to set up a basis for the nomenclature of chain, we must first define a term. The key word here is pitch. Pitch in roller chain is defined as the distance between centers of adjacent pins in a complete link unit. Now, let me repeat the definition. Pitch in roller chain is defined as the distance between centers of adjacent pins in a complete link unit. Now, when you hear a number denoting chain size, you are in essence hearing the pitch size of the chain. The number of a particular chain is usually in units of 10. For example, number 40 chain, number 50 chain, and so on. Two exceptions to the 10-unit progression are the number 25 and number 35 chains. Now, let me anticipate your next question. How do these numbers tell me what the pitch of the chain will be? Well, it's really quite simple. You put the number of the chain over 8. That's right, chain is measured in eighths. Now, let me show you just a couple of examples. For the smaller chain sizes, number 25 and number 35, we drop the 5, put 2 over 8 to give us 2/8 or 1/4 inch pitch. Put the 3 over 8, and we have 3/8 inches pitch. And a number 40 chain would be 4/8 or 1/2 inch pitch. And an even larger example would be a number 120 chain. Now here we would have 12/8 or 1/2 inch pitch, right? Wrong. What we would have would be 12/8 or 1 1/2 inches pitch, not 1/2 inch, as this indicates. Now using this last example, if you'll remember, the 1 1/2 inch pitch means that there's 1 1/2 inches between the centers of the pins. Chain normally comes boxed in 10-foot links, and to join the ends we have either a coupler link or a connecting link. Now the two units look to be identical, but a coupler link has a slip fit on the removable side plate, as you see here, while the connector link has a light drive fit on the removable side plate, like this. The smaller sizes are normally held in place with a spring clip, such as this, while the larger sizes use cotter pins, like this. Now, whenever possible, the connector link should be used instead of the coupler link, because the closer fit on the side plate extends the life of the chain. This is especially true when the service is severe. Now, if you'll remember, we said it takes two components to make one section of chain, a roller link and a pin link. Therefore, if we're to shorten or lengthen the chain, it must be done by an amount of 2 pitches, or 1 roller link and 1 pin link. Now, frequently, we would like to shorten or lengthen the chain by only 1 pitch. So in order to eliminate removing 1 roller link and 1 pin link, we have this unit. It's known as an offset link. The offset link is composed of a roller on one end and a pin on the other end. This allows us to shorten the unit by 1 pitch when that's necessary. Because an offset link is weaker than a normal connector link, it should not be used unless absolutely necessary. On regular chain, in order to be able to move, as we see here, there must be a clearance between every joint. The maximum clearance allowed in a foot of chain is 1/64 of an inch. Now that's 1/64 of an inch clearance each foot of chain. This means if we had an 8-foot piece of chain, the maximum allowable difference in length is 1/8 of an inch, and this is an appreciable amount. The point here is that most people believe chain is not flexible except in its plane of normal movement. However, this is not quite true, since there must be a clearance for it to move, as we've just demonstrated. Just as an example, let's assume this is a piece of 20-foot chain. If we take the lubricant out of the chain so that all the slack is available, lay it down on the floor and tie one end down or stand on one end, as we've done here, we'll be able to push backwards and forwards on the opposite end, showing movement of more than 1/4 inch. The chain will look well worn when actually all we have is the additive clearance which is necessary for the chain to move. This fact can cause potential trouble for you in larger sprockets, because as we wrap around a larger sprocket, we get this accumulative effect on the chain. And since the sprocket doesn't change length, the chain tends to want to crawl out, particularly if it's running at high speed. For this reason, we need to consider carefully any application that calls for a sprocket above 90 teeth to make sure that we won't have this problem. Let's take a look at some of the ways a chain might fail. First of all, there's fatigue failure. This normally happens with continued overload and is readily identifiable because this failure normally occurs within a 22.5-degree angle about center. You would have a crack something like this. Now this minute crack starts here and gradually works over until the chain actually breaks. Remember, this practically always happens within the 22.5 degrees off the center line. Roller fatigue is another type failure. Now, this failure occurs because at high speeds the roller is constantly pounding on the sprocket. Small hairline cracks first develop on the outside of the roller and gradually work through. At this point, the roller actually falls off and the chain must be replaced. Another type failure is crystallization embrittlement cracks. Now this happens in 2 ways. First, we get a crack similar to this when corrosive conditions exist and we're operating under relative high stress. The second place this failure is likely to happen is when nascent or atomic hydrogen is present. Now, this condition is found primarily around plating solutions. If you took a brand new piece of chain that's pre-stressed, put it in a plating solution, it will very possibly end up with cracks like this. This occurs because atomic or nascent hydrogen gets into the pre-stressed areas and forms the hydrogen molecule and is trapped in the metal in a space smaller than its volume and actually forces the plate to rupture. In certain special applications, such as heavy road equipment, there are special heavy series chains available. The heavy series has side plates that are thicker than normal, and also the pins are through hardened so they will be better able to hold up and absorb the shock. In addition to the heavy series chains, we have a number of other special types of chain. For example, here's the attachment chain, which is probably the most common special chain. We could have an ear on the side of each individual link, or an ear on every 10th link, or any number of other combinations depending on how the chain is assembled. Through these small holes, we're able to tie slats or any other material we might want to carry along as the chain moves. This is available with double side links, as you see here, one on each side, or straight up, as you see here. Another way of obtaining the same results is with an extended pin. This is where, as you see on the standard roller, a pin extends out, and we're able, for example, to run a small pipe between two pieces of chain. The pipe could fit over the end and be carried along with the chain. The extended pins are available in various lengths. Here's an example of double pitch chain. In double pitch chain, everything on the chain is identical to normal chain, except the side plates have been extended to twice the normal pitch. This is a normal pitch chain. The rollers on both pieces are the same size, the thickness of the side plates are the same, everything on both pieces of chain are the same except the length of the side plate, and it's been made twice as long. Since we have only half as many rollers on the double pitch chain, it costs less, and where service is not too severe, it serves well as a power transmission chain. The conveyor series, instead of having the figure-8 shape or wasp waist, has the straight side, as you see here, and this is known as double pitch conveyor chain. Again, on the double pitch chain, everything is the same except the distance from here to here, which is 2p, or twice pitch. And the power type series is wasp waist. This conveyor series has the straight side since it normally drags over something like a metal plate, for example, and we need more surface on the straight side to take that wear. These are also made with large rollers that extend beyond the side plate, as you see here. Consequently, as the chain rolls across a plate, there's no metal to contact with side plates, and you'll benefit with longer life on the chain. In addition to double extended, there's nickel-plated chain. Nickel-plated chain is used in corrosive conditions or when the chain is on the outside or in wet conditions. Stainless steel chain is also available, and on this chain all the components are composed of stainless steel. Another type, all bronze chain, is not as strong as regular chain, but has a place in certain applications. We have centered bronze chain, where the roller and bushing is all one piece. Actually, centered bronze chain is rollerless chain, since the roller and bushing is one piece. Centered bronze chain is also pre-lubricated. Now, the process is accomplished by taking a fine powdered bronze and pressing it together. This leaves small voids which are filled with lubricants. While this chain won't carry as much load as standard roller chain, there are a number of applications where we can't lubricate chain, and here the pre-lubricated centered bronze chain has a place. Since we did mention that this particular chain was rollerless, I should interject that number 25 and number 35 chain are also rollerless because physically the chain is so small you can't use a roller. Another type of chain we should discuss is offset sidebar chain. It's composed of a series of what is similar to offset coupler links. It's definitely different since the clearances are left larger so that when dirt gets between the chain, it's free to fall back out. This chain is used in the construction industry on such equipment as concrete trucks. Because of the extra large clearances, it'll hold up in these dirty, severe surfaces better than standard roller chain. In addition to the ones we've already covered, there are multiple chains. In this case, we in essence take two pieces of standard roller chain, put them side by side, and run a pin completely through the unit at every joint. This gives us double chain. Triple and quadruple chain is also available, and really there's not much limit as to how wide you can go. Normal stock availability goes through 4-strand chain. Now, one thing I might mention here is the use of double chain, for example, is that instead of getting twice the load carrying capacity of a single chain, you get a 1.7 load carrying capacity. For a 3-strand chain, you get a 2.5 load carrying capacity, and so on up the line. When we double up the strands, we do get more capacity, but the capacity is not in the same ratio as the number of strands that we add. In order to use chain, we must have sprockets, and there are a number of types. First, there's the A-plate sprocket, which has no hub on the side, as you can see here. Next, we have a sprocket with a hub on one side. This is called a B sprocket. And this is a C sprocket. As you'll notice, it has a hub on both sides. In addition to these, we have sprockets which are cut off and bolted here. This type sprocket is used in applications where we want to replace the teeth but cannot remove the hub from the shaft. Now, the ones I've shown you here are sprockets with normal stock bores. In order to put a normal bore sprocket on a larger shaft, you'll have to bore the sprocket out to size and put in a keyway so it will fit the shaft. There is, in addition, a different type hub, which is known as a taper hub. Now, there are 2 or 3 trade names for this type of hub, most common being QD and taper lock. The idea behind the QD and taper lock is basically the same. There's a slope on one side, on this side, and it's actually cone-shaped and has a taper on it. It's smaller at this point. The same is true of the sprocket that it goes in. The sprocket is larger on one side, smaller on the other side. The hole in the center is a taper also, and we've tapped holes in the sprocket here, 3 different places, here, here, and here, and this is a QD unit that we're showing you. On the QD unit, you'll put this section in place. It's already pre-bored, and as you can see, there's a gap here that acts as a spring. Now, as this tightens up in the taper, this gap springs in and tightens up on the shaft. This is accomplished by tightening up on these bolts, which pulls this down and pulls it in tight. Now, when you want to take this unit off, take these bolts and put them in these tapped holes. This allows us to jack the bushing back off the shaft. This procedure makes the unit easy to assemble, also gets us away from the problem of boring, since these hubs are stocked already pre-bored. In the case of taper lock, the same basic principle is used, but set screws are used to back the units in and out. In addition to the points that I've made, let's pose a hypothetical question. What do you do when you have 2 sprockets to install on a drive that uses chain, but you have to determine the length of chain needed? There are 3 things you'll have to know. First, the pitch of the chain. Next, how many teeth are in both sprockets? And finally, what is the center distance between the 2 sprockets? When we have the information, you may first of all go to the particular chain manufacturer's book, and it will have a chart you can use to determine this information. Normally, if you stock the chain, you will also have the sprockets in stock. So here's a really simple method for obtaining the information. Take the 2 sprockets, lay them on the floor, using the center distance required. You can then take your chain and wrap it around the sprockets. Using this method, there can be no question. An equally simple method, if you don't have the correct sprockets, is to look up the pitch diameter and lay it out to scale as we've done here. Lay a tape down on the scale and just measure right around. This is a really simple way to do it, but each manufacturer has his own method to determine the answer if you want to calculate it. The real problem here, as the center distance varies, this angle varies, and the wrap around a particular tooth sprocket varies. This makes the calculation somewhat involved. In summary, I'd like to make a few more points. Now, first,
we should try to keep from having less than a 16-tooth sprocket on most systems. A 20-tooth would be even better. This statement is true on applications using normal speeds. Now, at lower speeds, we can get away with much smaller sprockets, and this is frequently done. Secondly, we should mention lubrication. Design life for a piece of chain is 7.5 years if we don't extend beyond the loading it was designed for and if we lubricate properly. The most frequent cause of breakdown in chain is the lack of lubrication. We need to lubricate as much as possible. And while the most common method for open chain is a drip lubrication or even an occasional squirt from a hand oil can, if we are to get the full design life, the normal system will require an oil-tight cover and the chain must run in an oil bath. As the speed increases, now even this will not be sufficient and a pressure system will have to be used to spray the oil under force onto the chain. And since the speed and size of chain varies, the catalog horsepower tables indicate the various recommended lubrication systems. This has been Tel-A-Train's roller chain tape. Thank you for your attention.